Everywhere you go on YouTube or on internet, you will find that people are asking us to learn AI. Even I am saying people to learn AI. But before we jump into that, I think we should learn how to learn first. That is way more important than, directly jumping into learning AI. Because if we learn it incorrectly, it's going to take a lot of efforts and we are going to not make any progress. I see this a lot. People are learning inefficiently and incorrectly. That's why it takes them so much time. In my experience, uh, many people have worked way harder, but inefficiency. So, learning how to learn first. Okay, before I talk into that, I want to draw an analogy to a book, which is how to read a book. So, there was a book on that. This book talks about how you can read, and this is one of the only books in the market which talks about this. Isn't that interesting? We have so many books, but just one on how to read a book. And if you check into the its blog, this blog talks really nicely about it. And even inside this book, the details of how to read are not that detailed. So I wanted to say that how to learn, it's very important, but it's very overlooked skill. Similarly, how to read, very important, very overlooked skill. How to do courses, very important skill, but very overlooked skill. So to figure that out, I had actually given a TEDx talk. How to read a book. Not this, this. So I'd given this TEDx talk, how to read a book and actually learn from it. Let's see, that's me. So in this, I talk about a staged approach towards learning, and only when you check by the scale, you can say whether you are learning or not. So here I drew analogy, I gave a process through which you can check whether you are learning the book and applying its learning to real life. Okay. Similarly, how to learn deep learning, how to learn. Uh, so first point, learning how to learning is not made up of just one approach, but it is checked by combination of four things. Whether you understand its theory, whether you can apply that theory to a practical thing, so which in this case is going to be coding, whether you can take that practical skill and include it into a real life project. That's point number three. And whether that project is valuable enough so that it can be turned into a product which people will buy. This is the fourth pillar. So, by understanding, learning happens if you make progress on all four. Different people have different biases. I had a bias in theory. So, I made tremendous progress in understanding the theory, but not much in being able to code, not much in applying that coding into a project, and not at all in converting into a business problem and understanding whether that solution is sellable or not. If it is sellable, it is valuable. So my bias was theory. There are people whose bias is, coding. They jump into coding and they are able to quickly get something running. They can also get a project going, but they're stuck there. So in many a times, engineering college students I see, their projects are very simplistic. They are solving the same problem again and again and again. So that doesn't count as a project. You might be making progress in coding, you might be making progress in project, but it's not a real life project. You're lagging in catching up with theory, you're lagging in catching up with product. So that's the first point, which is, it's a made up of balance. It's made up of balance of multiple things. And check your progress in these four pillars. The fourth pillar is whether that project is, sellable as a product or not. And for that purpose, check Y Combinator. It's a startup incubator. It has many AI related startup companies. Or you can also check, let me show you Y Combinator. So here every season they have many new companies to which they give funding. You can check what kind of problems are being solved, or you can go to Stanford's deep learning course, which it's a Stanford's most popular course is this CS230. And here you can check the past projects of the students in this course. So this is good because Stanford, one of most of Stanford, they do start their own startup, and by checking how good the people students at top level are, you can check whether your project is up to date or not. If your project is a very old project, your knowledge is invalid. So a balance of four: theory, coding, project, and product. If you are lagging behind in one, your entire learning is actually lagging behind. It is not complete. So, first thing learning how to learn is understanding it is made up of four pillars. You need to make progress in all four. Okay. And in first month, you should at least be able to understand that do a project end to end, small project, but you can do it. You should also be able to code it, and you should understand that small project. So if in the first month itself you know that it's a loop of this project theory coding project product, so in that way you are never lagging behind in a single area. Okay, so that was the first point. Second point is how to learn itself is changing. The nature of expertise is itself changing. And as a proof of that, let me show you Gary Kasparov. Gary Kasparov is the world's one of the best chess players in the world. He's like Roger Federer of chess. Okay, his his one achievement is actually quite his one match is very famous. It was against a machine. I think it was Deep Blue. So Gary Kasparov played chess against Deep Blue, and Deep Blue was able to win. So at that point, we realized that AI, can play such a complicated games. What happened later to Gary Kasparov after losing to that AI? Now that is interesting because it tells us how the nature of learning itself is changing. So after losing, people thought that he has given a TED talk, by the way. I gave a TEDx talk. He gave a extremely amazing TED talk. You should watch it. The name of the talk is Don't Fear Intelligent Machines, Work with Them. He talks very nicely about how the chess field expertise itself changed when a computer was able to play better than humans. Humans were able to learn better. They learned for computer. They were able to build, learning plans, training plans a lot better. So that is why Gary Kasparov said that don't fear intelligent machines, learn to work with them. And he did that and he adapted. There was another person, go losing AI. Just like AI, he was a Korean world champion, Lee Sedol, I think. Yes, he was in the exact same situation as Gary Kasparov, but now playing in a more complicated game. So after losing, he did not have the same mindset about intelligence like Gary Kasparov did. The nature of the field also changed. It was a lot easier to it not easier, but you had a lot more intelligent partner with you to refine your game, and human skill uh, took a new heights with AI. Same in chess, same in AlphaGo. And going back to this topic, learning itself is changing. Same is in the AI as well. So use these AI tools to help your learning of AI. I was not very good at using Gemini. It is exactly the same message Gary Kasparov said. Don't fear intelligent machines, learn to work with them. There is one very important point you'll find in this lecture. Just because you are depending on a machine does not mean you are letting the machine do thinking for you. No. Working with the machine means you have your own POV, you have your own reasons. You are using the AI things result as a collaboration, as a feedback on what you decided. So if you just depend on the machine, then your skills will weaken over time. So nature of expertise is changing. Here you have to get used to using Gemini. Uh, it took me a lot of time to kind of like learn to how to think. So for example, I was studying diffusion, and if you have a AI system which can actually give us questions to any answers we have, we can customize our learning plan, or we can customize our doubts we have. So let's say you learn from a tutorial, it's highly likely that you won't get all of it. So maybe take that tutorial, ask Gemini to simplify it. Now you're working with the intelligent machine to learn AI yourself. You're not depending on the machine, but you're using it to make your journey easier. So nature of learning itself is changing. So to learn AI, use AI well, and you should be able to build a product and a project. So build your own custom AI, learn to use it better. So with this interplay, you will have a very powerful combination together. Going back to Gary Kasparov's TEDx talk, he had created a competition wherein human plus machine played chess, and together they were able to play a lot better than anyone individually. The same thing is going to happen in AlphaGo. There were a lot of progress in skills if you use this machine well, and same thing is going to happen here. Learn to use it well. It's not the amount of efforts you put, but if you learn to combine your powers with AI, that's like there's nothing like it. Okay. And then the final third point is check your progress by whether you can build projects or not. So if in 2 months you can't build a project, you are not learning correctly. If in 4 months you are not able to build even more complicated project, you are not learning correctly. So by having a feedback of checking when you're not learning correctly, you can course correct your journey in the way. So my journey was actually quite difficult. If you check on GitHub, you will find I have been trying to learn AI since 2023. I was doing that, since January itself. From January to May, I focused a lot on theory component, not much on coding, as you can see here in the graph. So it was a bias learning. Then I started focusing on coding part, and I focused just on coding here, not much on the projects. Second mistake. So it's towards this end of 2023, I realized, I learned to combine theory plus coding plus project, and welcome to 2024. Where is that project? It's things like Kaggle competition, and to any model which is running on Hugging Face. Those are projects. Even now, I have not built a sufficiently good product which is valuable, but I've done small projects. So by combining these things, learning to how to work with Gemini, doing a combination of theory plus coding plus project plus product, is how my learning has become a lot better. So if you want to learn AI, just don't just jump into it. First learn how to learn, and then go into this field trying to learn the essential technology of future. Very powerful, so do learn it. I will repeat the message, but learn it well. Ending quote I will say from my TEDx talk is, you learn more by reading one book 10 times than reading 10 books once. Its corollary is, you learn more by reading one great book 100 times than you learn by reading, good books 10 times. So great books, they should be done thoroughly. Similarly, here also focus on few learning resources, not, just list of courses like how we have on internet. No, focus on few, learn them well. You do them well, you learn by doing one thing thoroughly, and check it with these four pillars: coding, theory, project as an application of the knowledge, and a product which is sellable. So if you check in this all four dimensions, your journey of learning will be a lot easier.